Good morning, everybody.
Good morning.
Good morning, sir.
Good morning, sir.
Actually, today's topic is recent advancement in microextraction technique. Actually, when microextraction technique, people going to the what is the extraction technique. So numerous question is trouble and knocking in your head, but this microextraction is not a recent advancement, but that advancement are going. Actually, that talk actually cover up the main fundamental extraction of micro extraction versus the exhaustive extraction, and some integration of sampling and sample preparation, and some calibration model quantification of SPME, basically is and diffusive and kinetic calibration, and extraction of heterogeneous matrices and matrix compatible extraction phases, application and summary. Actually, paradigm everybody in fundamental change in approach and underlying the assumption, and paradigm shift means a change in the perception how things should be thought about, done or made, means reality of the thinking. So in that way, if you are a shifting of the paradigm, you can go into the extraction process. When you prepare the various analytical samples, means then there that four things are in your mind. First is sampling, second is sample preparation, separation and quantification, then statistical evaluation, decision, and last one is action. Sampling is a art. Actually, where you various regions of samples as a environmental source, as a biological source, as a natural product source. So sampling not a easy task. So in that way, according to nature of these samples, your collecting of the sample also dependent. But when sample preparation basically in traditional process of the sample preparation, you going to the some extraction process, maybe you name the percolation, shottlation and maceration. So in that way, 24 and 25 types extraction process according to nature of the samples. And separation science basically you're going to the chromatography, means if you are a liquid chromatography and high performance thin layer chromatography, this is a separation science. And quantification, if you are interested in quantification, sometimes sample is profiling either or fingerprinting. Profiling is ultimatum quantification, and fingerprinting is just as a fingerprinting matching. And next one is statistical evaluation. If you are your sample source is new and you introduce as a new method, then there help of the statistical findings. Statistical evaluation, if you are going to the ICH guidelines, there some statistical parameters are given that are everybody know, they are all are established. Precision nothing but a repeatability and reproducibility. If your method you optimized one method, you transfer in another lab, then that method must be in precision means repeatability. That repeatability may be as a statistical findings means relative standard deviation. Then accuracy. If your method is what is the accuracy level? If you are as a standard, if your isolation is a natural product in ashwagandha, means withania somniferum root, that is a ethanol in steroidal alkaloid. This is on a reference standard is available, but you separation and quantification is a new method, and then that method previously not published, or then you check the accuracy level, the existing methods and your new method, and that accuracy data may be represented in student t-test. Then the heart of the instrument and limit of detection means this is a linear range. Your method is linear, the heart of the any validation method. Then you are going to the most essential sensitivity, means limit of detection. Limit of detection you can go solve S by N, means signal versus noise. Noise is nothing but a blank. S by N ratio is 3, and the limit of detection S by N is equal to 10. In that way, precision, accuracy, linearity, limit of detection, and limit of quantification. And last decision is robustness. How your method and your new existing method is, how much is robustness and rapidness. So in that way, you can help the artificial intelligence and some chemometrics techniques. And this is nothing but a chemical measurement with this is a chemical measurement with help of mathematical statistical findings, means pattern recognition. In that way, you can also reveal the expert systems. Explanation about sample preparation. Sample preparation in traditional system is an art, but nowadays that sample preparation, the artistic with the very take time for doing. So that's why they are interpret the science. Some application scientists they are used. They modified their method and optimum their extraction method, sample preparation method. But academia, their sample preparation interesting. They are teacher. How they thinking their sample qualifying. So actually good choice of sample design give the additional information about the existing investigating system. Sometimes nature of the samples previously said solid, liquid, and gases in that, and some interfering species. That is also most important. What is the interfering species? Nowadays is green chemistry, means that's the eco-friendly analytical chemistry. Is if you reduce the toxic chemicals and also generate the waste, and engagement of screening method means sometimes you can high throughput screening and you screen the 100 drugs and you are that screening is qualitative, yes or no. If you are a quantity, then your method may be going wrong long run, and your sample and solvent also take huge amount. And sometimes you can change the exchange the toxic substance. And also some, if your extraction process is large scale, you can, that solvent must be recovering with the help of rotor evaporator and lyophilizer not rotor evaporator in that recovery reagent, and online decontamination of waste, and reagent free methodology. That is a green chemistry, reagent free methodology, and on-site in vivo technology. Just so in that way, you this is the eco-friendly of analytical chemistry, that paradigm is set. This is extraction. Extraction phase, everybody knows, is the distribution constant, is partition coefficient. One is extraction phase, another is sample matrix. What is the exhaustive extraction versus microextraction? Here I take one example. If you are a exhaustive extraction, liquid extraction, you take 1 liter of samples and you take extract 40 ml of solvent, and that after solvent evaporation you take the 5 liter. So that solvent evaporation, solvent going to the nature, and that hazard the ecosystem, and afterward inject the 1 microliter your instrument, high penetrating instrument, the HPLC, PTA, LCMS, that type of instrument here. And micro extraction is your sample is large volume, but you take just as a one extraction device, that is a one fiber, and that fiber you can see that that fiber to just dipping here, and according to nature sometimes you can head space also, and just directly go introduce your instrument. And this is the beauty. If you are going to the existing table, there is everything is identical. Why microextraction is more efficient? But microextraction is more efficient due to sometimes enrichment of extract. Your extract containing target component may be in trace amount. So in that way, you can just minimum volume of the microextraction, minimum volume of the sample can be taken. So this is the beauty for the microextraction. And different type of microextraction are available, and based on this solid sorbent and based on the liquid sorbent. Sorbent means nothing but a adsorbent layer, and that adsorbent layer actually they are classified solid phase microextraction, in tube solid phase microextraction, needle trap device. Needle trap device, just I can example, there's a breath analyzer. There's sometimes some protocols are used. This is a one modification of needle trap device solid phase microextraction. And based on liquid, and that liquid single raw microextraction, hollow fiber liquid phase microextraction, and dispersive liquid microextraction. But my talk I'm going to the only solid phase microextraction. So, who discovered SPME? Professor Ferguson in 1990, University of Waterloo, Canada. That is a solvent-free adsorption and desorption. He invented this technique, and this the basically need for fast and solvent-free and compatible for preparation method, which is first and more efficient the name of the game in the industry. And microextraction in this main idea. What is the microextraction? This is solid phase. Solid, it is a rubbery solvent, just like a rubber in nature, not actually chemical in rubber. And microextraction volume of the extraction is small compared to the volume of the sample matrix. It consists on coated fiber that isolate the concentrate analytes into a range of coating materials. And that after extraction, this fiber transferred into analytical instrument for separation and quantification of your target analytes. This is a series-like handle device that protects your sample while transferring your sample to the instrument. Because this solid phase microextraction, this is a four basic technique. At first, you conditioning your fiber. Second is washing. Third is desorption, and fourth one is your instrument. This is the four basic, because we're going to the basically a micro extraction technique. This is the three main technique. If you are going to the SPME configuration, basically you can all are established various dimensions they are used, and some fiber and in tube also, some vessels also, some suspended particles and stir and disc. If you are interested, any that book are available in. And this is the more this basic idea how SPME is configured. And mode of SPME solid phase microextraction operation. Actually, here this is a fiber, and that fiber are taken is a one sample containing liquid, just as a schematic diagram. And that mode of operation is basically three: direct immersion, headspace, and membrane protected. Direct, they are used in some condition in nature of the samples, and headspace also more appropriate now. Various if you are a various gases sample, air gases, naphthalene are available in city air, and that is the headspace is the most important findings are given. There is literature articles. If you are a theory and practice in solid phase microextraction, and now newly in membrane protected, because this is costly instrument, costly fiber. So that fiber, when are repeatedly used, and that membrane may be membrane protected devices are nowadays available. And this is the design of first commercial SPME solid device by Supreo company. Actually, this is one syringe are available, and that syringe are protected, and that way that layer, the needles are, this is a fused silica fiber. That layer means a small layer means it might sometimes maximum is 10 millimeter. But maximum 10 millimeter, there is some basic problems. You can 40 micro minimum you can go. This is the best resolution and going to the sensitivity issue. Nowadays, evolution of SPME technology was starting in the SPME origin is fiber. Then patient is you can fish analysis. You can also direct SPME gun are available, and also some doctor personnel drones. So in that way, yes, SPME technology are going to it. When solid phase microextraction is going to the initiation, there must be some things are theoretically sound, basically equilibrium calibration, where only two phases, basically two phases, the sample matrix and extracted, and that N here is equilibrium. That mathematical expression written, the extraction of equilibrium can be described with that. And on-site equation, sample volume is constantly large. Then, if your distribution coefficient is a given analyte is known, then the concentration set analyte can be measured. And that calibration also successfully published. And some boundary layers, SPME diffusive calibration, because sometimes when your device fiber are there, that is a computational simulation study the flow velocity of the diffuse layer. Basically, in the sample matrix, the flow velocity. There is significant constant diffusion with the flow velocity, agitation of the sample matrix, and control thick diffusion layer and sample rate. And this is diffusion means if you are your coating fiber, adsorbent is maximum layer, and that may be sometimes flow velocity hampered. So in that way, just diffusive calibration sometimes according to going to not fixed law, you can go that diffuse calibration. Sometimes some device must be needed for the optimization for solid phase microextraction. And kinetic calibration, because sometimes kinetic calibration also needed, because extraction rate can be equilibrium, speed, volume, the extract, and headspace, samples, mass, transfer and partition coefficient, and surface area of the extract that is dependent. So during extraction process, if you are calibrated your instrument, then preloading the international standard of the extractant prior to the deployment and device of sampling. If you are in target analysis for profiling the your samples, because sampling of the complex system, because sometimes this is on a schematic diagram. Here, SPME fiber, needle-like fiber are used. A headspace you see some bubbles are came. That bubbles are going to the needles. This is a headspace. But when the SPME fiber is aqueous space with matrix, the matrix bound component sometimes free, and that way the equilibrium achieved. When equilibrium are going, this some free component are going to the SPME fiber. So in that way, in complex environment, you can sampling your particular solid phase microextraction process, because if you are a conventional technique where there is some interferent species may be present and your data not a good resolution and good evaluated data you cannot not generate. Actually, sometimes in this is I just briefly the coatings. Coating of the means I am going to the fiber coating. Some nowadays in carbon nanotubes are used electrothermal mechanical stability, a high surface area, excellent absorption energy, and graphite carbon boronite nanotubes, seeds, and metal organic frameworks, geolytic imidazole frameworks, and covalent organic frameworks, and molecularly integrated polymers and ionic liquids. Then that coating materials, they also some in the industry they are developed, and some they are developed that coating materials for due to the sensitivity and specificity of the particular device, solid phase microextraction device. Actually, just I touch some portion. There is a single wall carbon nanotubes, 3 nanometer diameters, and multi-wall carbon nanotubes in 100 nanometer diameter. Basically, layer is graphene layer, but that graphene layer sometimes in conducting and semi-conducting properties, because thermal, mechanical, chemical stability is good. But hexagonal arrays is carbon atoms in graphite 6 in a single one carbon nanotubes and reveal strong interaction with the other molecules, make them proper solvent for enrichment process. Means enrichment means your target analytes concentration increases, and sometimes oxidized CNT with single wall carbon nanotubes layer bovine serum albumin to extract lead ions from untreated human samples. Well, means that integration nowadays solid phase microextraction are available in market, and now good and molecularly imprinted polymer and ion imprinted polymer. This is 3D structure produced by reaction target compound. This is a template, and proper monomer pages is cross-linking agent and provide cavities and selecting recognition imprinted molecules after polymerization process. Or ion imprinted polymers start with the reaction between metal ions and ligand from a complex, and after polymerization the imprint ion can be leached from the polymer structure using the proper solvent, just like the example is a mineral acid. So, and this is the coating materials now. Here 5 types of polymer coating are available. This is the I previously described, and nowadays is matrix compatible coating. Nowadays that fiber going to the blade, mesh, and reassess SPME. This is the most advanced recent advancement, and with deep coating. And that biocompatible coating basically, when in the sense that biocompatible coating basically
नहीं हमने नहीं ली आपकी एक भी पिक नहीं सेम क्या पड़ी नहीं उसने मना किया નથી આ નથી
that and that matrix compatible basically there is a PDMS outer layer in 10 to 20 micrometer, and that layer are coated the fiber, they protect the fiber. And nowadays HLB particles, hydrophobic and lipophobic balance particles embedded also in available, and that is a solid phase extraction sulfuric particles embedded in pan also available. So in that way, and that biocompatible coatings nowadays give good outcome and good reproducible data in analytical, in clinical findings, clinical data. Yes, this is shape of sharpened device. Actually, device geometry. Basically, we people are end user, but we think little bit about the this structure. The SPME fiber. Basically, if you are targeting in vitro cytotoxicity assay, this SPME fiber is a good result and good sensitivity. If you are a thin film SPME, this is a nowadays a good TFME, that analytical sensitivity is very high and fast extraction kinetics. And some DSPME means dispersed magnetic nanoparticles emerging geometry of SPME, enhance more sensitivity and rapid extraction. And last one, stirred bar short clip extraction. Basically, that extraction is stirred bar inbuilt, a magnetic stirred bar, and increasing sensitivity through thicker extraction phase. So, nature of the samples, that shape of the support of the SPME device also changed. This is I going to the previously said that the balanced cover is hydrophobic compounds. This is a good application. This if you are a biosimilar compound, this is a macromolecule. If you are a biosimilar nowadays, US, China, they are going far for the biosimilar compounds, and that binding molecules. If you are they see the picture, there is boundary layer. That layer is static. But when your small hydrophobic molecules, that high kPa value and low free concentration in the tissue, but high protein binding. So in that way, they are going to first, and with small hydrophilic molecule, low kPa value and high free concentration in the tissue. So in that way, that type of C18 benzene sulfonic acid coated and phenyl boronic acid coated balanced coverage, the fibers also available for the non-polar and polar component, basically macromolecule in biosimilar component characterization. And that balanced coverage, if you are doing the diffusion layer, and if your diffusion layer is diffusion layer means your thickness of the fiber is small, then diffusion is smoothly and strong. If your thickness is high, and that diffusion process may be hampered. So in that way, then balanced needed, and in that interplay is your distribution coefficient and your extraction coefficient. And because if your solid phase microextraction is introduced, there must be recovery rate at least 180% needed. So that's air extraction time in 50 minutes. But analytical concentration is 100 nanogram per ml. So when hydrophobic coating, their low distribution coefficient and low active extraction coefficient. So in that way, the extraction recovery basically varied one order to the magnitude. Means if your layer is uneven, if you have seen the color of the red and the blue, and that is the even layer is, then you get your diffusion calibration also maintained, and this is the balance. Basically, this is the ion exchange affinity coating is basically exception, and that articles also. This is a good article in 2018. This is published. If you are anyone to read more information, this is a diffusion information, diffusion calibration information. That articles give more information. I am going to the actually solid phase extraction and solid phase microextraction difference. Actually, solid phase extraction nowadays various people are there used, but this is a packed column. SPME is an open way, no need for pre-treatment of samples. Solid phase there is a need pre-treatment because when you sample your sample collected at drying and then Soxley. And after Soxlation, you then going to the your high instrument. Then you at first be flash chromatography, they purify your extract because when you charge your extract in hyphenated instrument chromatography, your column must be true. Means sample cleanup must be needed. But SPME, there is a minimum volume of your sample needed because when you take 1 liter of samples in 1 microliter, because water containing that trace amount is 1 microliter is also available, 1 liter is same concentration available. So that's why that is a open bed and no need for pre-treatment of samples, no need for solvent use. And this is a exhaustive method of extraction because you had at first drying, oxidation in 24 cycles, then your rotavator drying, then afterwards in again solvent dissolve, then afterwards you going to. Here is a non-exhaustive technique. Just you can follow the equilibrium and kinetic calibration. This is only two. And breakthrough actually basically in the limit of volume, loss efficiency, limit of sensitivity, and multi-target analysis. But here that is a limit. When if you are a sensitivity limit, multi-target. But solid phase microextraction nowadays in metabolomics and multi-target means if you are a I am it's a traditional system. This traditional system I give huge time, and they believe that one drug is a second as a weaponolite. Means they act as various systems. And if you are a preparation that is a multi-target, and that you can adopt the SPME, cannot be that traditional system is not fulfill your demand, and the possibilities of automation. But because disposable separate short column and cut is if you are used 1 times, that is not regenerated. It's 2 times and maximum 3 times. But here that is easy to automate. The reusable 96 blade SPME coating is now available because that is a high throughput and fast samples. You can monitoring 96 different samples in just 1 time. And that concept actually available BIIS technology, that is 96 well manual unit. This is portable. And actually SPME, solid phase extraction, collect matrix during a matrix event. Percolation is a matrix event, but here is cleanup method. Minimum matrix effect, minimizing the organic solvent consumption. Finally, say this is a green chemistry. And this is the first technology and 96 blade system. This is a that fiber is modified and solvent layer. Nowadays application. What is the actually developed and numerous articles and numerous nations they also follow that SPME. Flavor and fragrance investigation, environmental analysis. This is basically complex samples and bioanalytical application. This is also complex environment. If you are collecting serum and blood and tissue, so this is a complex environment. If you are target in untarget analysis, that area SPME is a good result and good reproducibility. Analysis of wine. Ocratexin, this is wine volatile, so that's also SPME. Good to 3-4 paper is available. In vivo analysis is pollutant. On-site analysis of soils. Actually, I give some basic case study how on-site of analysis is soil. Analysis of water samples. Sometimes food analysis. Food analysis that SPME is a good outcome in vivo and in vitro metabolomic studies. And pharmaceuticals also, and biomedical analysis nowadays they use that SPME technology. Actually, food analysis, your aroma profile. If your aroma profile 3-ethyl 2,5-dimethyl pyrazine and benzothiazole, if you are a apple analysis, that two chemical give the best aroma. And that aroma profile you can in apple just you can just take a direct immersion in apple and just analysis that two chemicals how much quantity. And food safety assessment sometimes some food producing animals, the cattle, and they are deliberately fluoroquinone antibiotics are given. But that food producing animals in some eggs, if any milks, and that antibiotics assessment because that two samples is a complex environment. If that complex environment your target moieties in fluoroquinones, you can search and profile it, must be needed the SPME because traditional process is huge time and that not fulfill your demand. And characterization of edible soils. Sometimes nowadays the some adulterated various oil are mixing because that type of market various country and India like also available. That type of practice are going. So in that way, if you are a characterization edible oil, just fiber immerse before conditioning, then adsorption is happening, then afterwards you deception and then going to the analysis and determination of sucrose in honey because every various numerous honey are available in market, but their sucrose determination and traditional process, this is a take huge time. If you are a chemical fingerprinting, means if you are a polyphenol and some flavonoid, some alkaloid and some glycoside and some steroid and some terpenoidal component. And there are various class of component. Polyphenol flavonoids here, this is a medium polar. And alkaloid, this is alkali in nature. And their polarity is different. And if you are a quaternary ammonium alkaloid, sometimes your last food practice, our lab, their water extract. If you are a water extract thinking, their water extract sometimes their quaternary ammonium alkaloid are coming. You quaternary ammonium alkaloid, what is the quaternary ammonium alkaloid? That is a theophylline, theobromine, and caffeine. So this type of target moiety may be present. So when you choose your solvent, but here water extract polyphenol propanoid must be present coming. If you are a polyphenol propanoid as a directive, means neem. Neem is your biopesticide, you are huge. Because neem as a directant is the main active marker that is for use for the various insecticide and repellent in that way. But that as a directive maybe reach some amount. If you are water, that is a 10 ppm to 100 ppm would be increasement. Because polar is like polar. Your target class of moiety is different, then polarity is different. If you are a hexane as a neem, as a directant came in 1000 ppm. So in that way, when polarity is differ and your target class of moiety also differ, and metabolomic investigation means cannabinoids, and nowadays everybody knows some this is a nation problems everybody are used, and that cannabinoids actually if you give this shelf life in 7 days if anyone takes, and you can also the breath analyzer you can also investigate it. Some SPME technology and determination of nutraceuticals value. This is primary metabolites. Nutraceuticals means carbohydrate and protein and fats. Total carbohydrate, total protein, total fat. Because they are different nature. So their SPME technology in that way good. This is a different class of extracted metabolites already and published in various reputed journals. Is flavonoids and pyran moieties, indole moiety. Indole means you are indole type of some alkaloid with if you are going to the reserpine, still means this is a flavonoids, and isopenoids means isopenoids you are going, isopenoids means this is a terpenoid component. Isopene unit is available, and that monoterpene, diterpene, and triterpene and tetraterpenoids. And finally, lycopene also is a terpenoids and carbonyl components. So in that way, means if 100 to 1000 molecular weight, they are well documented, and a log p value means log p nothing but a partition coefficient logarithm value, and minus 7 to 15, that chemical distribution coefficient that they are validated previously method and the solid phase extraction, that different classes of extracted metabolites. Recent that basically in vivo sampling success, because SPME, because sometimes when you are studying with animals, means the various nations the animal studies are they stop there. But if you are a toxicity analysis, then must be needed animal toxicity. But one thing, if your one group is 6 animals, control group, and another treatment group is 6 animals, their inter-animal variation is possible. So in that way, if you just monitoring one animal, the SPME monitoring their actually brain analysis, if you are in brain analysis, if you are in the blood samples analysis, their lipid profile, their urine profiles, in that way, terminal blood also. So in that type here is HLP-SCX, means hydrophobic lipoprotein balance coating single charge fiber are available, and this is a one type of solid phase microextraction. You can analysis the, if you are a pharmaceutical field, pharmaceutical fields, even in drugs, their pharmacokinetics profile that may be maintained, because if you are a drug gives and that drug ultimately reach the bloodstream, if you are a time specific that blood is collected, and that the your target component if you are a analysis, then you go into the statistical finds in the existing method, and just dipping and sucking. This is a one type of loop are available, and that loop is suck the blood, and that fiber you can use repeated animal. But in that way, minimum of animals, group animals, you can animal variation may be diminished. This is actually SPME in vivo SPME extraction in fish tissues. If you know the tilapia fish, one type of particular fish are available, and geosmin and 2-methyl isogonal. This is a produce cyanobacteria, and that actinomyces, which are major source of the earthy, muddy smell of the flavor of fish. So that type of fish materials, you can use the coated C18 composite coated fiber and deep the coating the fiber and polyaninyl and bioimprinted PNE in vivo sampling fish affixal muscles you can just sampling. So this is the fish tissue is on site. You just fish market. If that particular fish market, if any group, any physical observation, there is any problematic, and you can easily sampling that there must be any cyanobacteria is present in that. And now in vivo extraction in plant tissue. Nowadays, basically various sampling different organ, leaf, stem, and root. If you are researching particular one marker, moieties, how much quantity is leaf available, how much quantity is stem available, how much quantity is root available. And this is a custom made PDMS fiber. there is a Malabar spinach. So you can just fingerprinting or the profile, the various region of the plant. So some plant or root are used most important. If you are target the root at the active moiety, so every time plant are cut out. But just you can search the root is the one source. Second source is stem is available and leaf is available. How much quantity is available, and that type of study is needed because nowadays plant are vanished. Every plant are they are marketed in various other nation. So that's why value-added medicinal plant value. Sometimes the root, I just change the leaf. So just at first check the phytochemical metabolites and various class of metabolites are how much quantity is available. And environmental analysis extraction of pH from certified various soil samples and soil samples in this is a spatial balance is PDMS CPC the fiber is available, solid phase microextraction. A rapid scheme of selecting pharmaceuticals for treated wastewater. And on-site extraction is basically benzene and naphthalene in CTA, and that is a particular of PDMS TP, thin film solid phase microextraction. Afterwards, hyphenated instrument GCMs. And this is an on-site portable TFP extraction apparatus with GCMs. Because you can see this is a membrane and also NTD here available. The portable GCMs also is on-site. Sometimes you can go into particular one region, but our organization going to Sojata. So in that way, their sampling, they are called various sample, and that samples are going to various storage. But if any positive findings, this is a good, and in that circumstance, on-site portable TFP extraction with GCMs give the good positive outcome. So, and this is a future perspective. This is the last portion of the perspective future direction. Actually, nowadays, finally paradigm shift, basically super technical, solid phase microextraction. There is no need for any separation. They are omit the chromatography. They just various sampling preparation prepare the fiber and direct the MS analyzer. This their open port probe to transfer capillary and ionization source and mass analyzer. Their vacuum create, and in that way open chamber ionization ambient conditions and nano ESI electronization spray ionization and spray device they are used. This is a perspective of future direction for the microextraction. They are omit the chromatographic separation. They are going to the mass because mass, if mass data is available, mass lab data available, you can search your new component, match the mass library, you can easily. So this is the good for the green chemistry. You can just minimum sample preparation and direct mass analysis. And for summary, this is a flexible tool, and different biological matrices including this one you can use, and this is the good analytical coverage. And if you are a fully quantitative analysis, SPME, TFP discipline, and many minimum invasiveness per time course or no minimum damage of the organ. If you are a organ in lungs carcinoma, and then just you can also as a fiber just no damage the organ, and technology get down in the graft function, drug concentration and distribution. I just mentioned the graft function. This is a new technology. Drug concentration and distribution means nothing but in pharmacokinetics. And if you are a SPME microgen cell line analysis, temporal resolution, no sample preparation, direct. And SPME is a coupling could be as an intraoperative diagnostic tool in the near future. And this is our lab. Thank you. If any questions regarding solid phase microextraction. Hello.
Students, if you have any question, you can ask. Or if you want to discuss anything. Hello. Am I audible?
Yes, ma'am.
Yes, ma'am, audible.
Okay.
There is no question, everybody know the solid phase microextraction. So if anyone question, you can chat the ma'am also, and also